Thank you. I appreciate that. Um, I was just gonna say, okay, we've just got a couple of quick pull request things here, and then we can really, get back to the paper. So uh,
Yep.
there's only one pull. There's no new pull request I saw related to performance, and the only closed pull request was from Majian Peng that got closed by the stale bot because no one's looked at it. So that's what it is. Uh, Two that were updated. Another one from Majian Peng that Adam and I both reviewed that looks good. That's just changing the flushing behavior for Blue Rock's environment. Um, and yeah, that looks like the right move. Then there was another one that was updated from Eric regarding RGW ordered list map efficiency. And I believe that Casey did actually review that now. I saw that there was some discussion on it. But yeah, movement, so that's good. Um, Not a whole lot else going on right now, though. So that's it. All right, do you want to take over here and get us going on the paper?
Yeah. So should I quickly introduce it again? Because I think we have new people that weren't here last week, so I'm not sure.
Yeah, I think that'd be great.
Okay. So to the people that weren't here last week or didn't get a chance to watch the video, last week we discussed about a paper I came across from Fast 20. The paper was introduced about 6 months ago, almost 6 months ago. It talks about, it introduces a new, like an extension to the crush algorithm. The motivation to that basically is that they found that Crush is suffering from data migration when there is a non-trivial cluster expansion happening. So the point of the paper is to overcome this issue by adding sort of time dimension mapping, which means that each object has a timestamp, and when you expand your cluster, you don't migrate most of the data, so that you only write to the new OSDs, for example. And they're also talking about how they are addressing the potential load imbalancing by doing that, because the reason there is data migration is because you're trying to perform load balancing between the different OSDs. So that's kind of like the idea in a nutshell. Yes. Did anyone get a chance to read into that more? I'm also going to link it again in the chat. So this is the shared doc on my drive, which contains the paper and kind of the highlighting and marking of stuff that I found useful or important, just to make the reading experience better. And I'm also going to link just the paper itself, because the shared doc is only available inside Red Hat. So if you want access to that, you can just request. And I'm also going to link the paper from the website. So
The
link
paper
I
you linked with
just
the highlights
sent.
is really good. That's really nice.
Thanks. So
Yeah.
the second link I just sent has both the paper and the presentation from the conference. One important note is that the video from the conference is not, the presenters are not the writers of the paper, because they couldn't make it due to COVID-19. So the person who's presenting it is just basically reading through their notes. But if you want to look at the slides and maybe some of the explanations, you can take a look there. So I guess I'll start off by one thing that really caught my eye in the paper that they talked about like multiple times is that they did their experiments only on Ceph RVD, on RVD and Cephfs, because they said that this method cannot be applied to like general object storage. Do you see that, Mark?
They did say, they did say that they are continuing to work on a future implementation, trying to reduce the cost for general objects. I didn't see any new publications from these guys on future work they did in the last 6 months, but they did say that.
Yeah. Also, Roden, I tried reaching to them last week. I sent them an email to the people who wrote the paper to try and maybe get them on one of our meetings if they want to present their work, but I still didn't get a reply. Mark, you can make sure that I CC'd you, so you and Josh.
By the way, you're a bit broken. I'm not really okay here for me. I have a few questions, comments about that. Okay.
Go ahead. Can you hear me now?
Yeah. No, yes. One issue is that, like you said, they are using timestamps, and they are using timestamps that, at least for the file systems, they are a bit contrived. They are using the creation time of an object, which is something that.
Of a file, you mean?
Sorry?
Right, because in Ceph, so what they're doing in the file system, they're not using the timestamp is not of the object creation, but rather of the file creation, because they want to work in a file granularity.
Yeah, of course. They're using what the POSIX, if I understand correctly, they're using the POSIX file creation data.
Yeah.
Which.
Pretty sure.
Okay, it's interesting. But for the block devices, they're assuming a stamp, a timestamp will be available to the client.
It really doesn't matter. It doesn't matter how the timestamp is generated. All that matters is that when they go to look it up at the push map, you compare a number to whatever's already in there. There's no need for any kind of particularly accurately kept timestamp. It really doesn't matter how it's generated.
Yeah, but the idea is that there are two limitations. One, it is something that is always incrementing, monotonic increasing.
Not
and
really.
The client has to. The way they build it,
you can create an object with an older timestamp. It just means it'll be placed on an older layer. It still behaves correctly.
Yeah, but the layers should be timed in increasing order. They're running on an older set of layers.
So for that part, the monitor can already create monotonically increasing numbers. That's not really a problem.
Okay, and this is okay, and I think what's more important is that they're introducing what seems to me a lot of complexity in the management of every algorithm that needs to compare or recreate or repair the data. for something that is only meaningful in a very specific and very limited scenario of expanding or reducing the size of the cluster. So it seems we are using it means paying a large probably price in complexity for something that is rarely used. This was and the solution is not general. It's different from file system to, as it is there, from block devices to file system. I think it's
that struck me as well, Vernon. It is a kind. It struck me as well, Vernon. It's kind of a constant or a cost that you pay over time for something that is beneficial, probably for a relatively short period of time.
Right. So the cost, as far as I see it, is that you increase the number of PGs basically linearly over the lifetime of the cluster, which is pretty fatal, actually.
But the assumption that every time you're doing a cluster expansion, you're creating new PGs, is that the main assumption of this paper?
Yeah.
But
so
that's not the case with current.
Yeah. Sorry. Go ahead.
No, go ahead.
I was going to say there's a sort of a difference between there were a couple of different dimensions that I thought were interesting here. One is that using an externally stored placement key, which is I think what Ronan was reacting to, that you have to store separately, is actually a very cool idea. It allows you to distinguish how items are placed based on external details, like for instance, they use creation time. But that's not the only way to do that here. So that is an interesting concept that we might wish to steal. So I thought that overall this strategy is essentially analogous to allowing pools to have more than one crush map mapping rule with essentially different pools of PGs under it, which is also interesting. The problem here is that they go further and say that every time you create a new expansion, you literally don't change placement of the older data. And because of the way Crush works, that essentially implies that you need a new pool of PGs for the newly created objects. And I think that's where you get into trouble, because in the long term, you do actually want data to be uniformly distributed. So ultimately, they address this with layer merging, where you gradually remove the timestamp distinctions between the different PG groups, which essentially then means that all of the PGs are placed using the same rule. But the PGs don't go away, and the original static timestamps don't go away. I believe you have to keep both of those, or the objects move between PGs.
But they are doing the cluster shrinking too. They are doing three things they're doing three things to address the potential load imbalance. So they're saying that this PG remapping, cluster shrinking, and layer merging. So it's not just layer merging.
Right, but none of the other two don't remove the number of PGs, which is fatal. That's the problem. Those things all taken together, the end result is you have a cluster map with an ever-increasing number of PGs and this static mapping, which doesn't go away. Other mitigations don't appear to address that.
I didn't understand why they are not allowing a removal of that.
That's what I was getting at. So it is, however, possible to do PG merging, even under these conditions, but the end result will be that data moves. That would be the whole point. As you converge back towards the original number of PGs with the new crush map, you end up back with our current behavior, just with a longer circuit. This is not a bad thing. A longer circuit means you have tighter control over the rate at which data moves, but I think there may be simpler ways to achieve this. For instance, if we take the same sort of multiple crush rules under a single pool approach, but instead of creating new PGs, we simply say, all right, so we have the old crush mapping and we have the new crush mapping, and one PG at a time, we're going to shift which PGs are mapped by which. We get essentially the same behavior we get now with temp mappings, but without needing to store a large temp mapping set in the OSD map. The disadvantage of that approach is that it will move a bunch of objects in line with how it changes the placement of new objects. But I think that's actually a virtue, not a vice here. Sorry, go ahead, Ron.
Just to following what you said, this was my initial thought when I read this. Did we consider, you know the history, did we consider using having multiple maps and just provide a way for the client, either by trying all maps or by some other option to use to select which map to use?
I'm not sure I understand what you mean. So all clients need to agree, right? And trying maps isn't really an applicable concept here. You'll get a valid mapping either way. So what I'm suggesting is that the current map has more than one crush rule for a particular pool, which in this case would be two different hierarchies, one with the change and one without it. And you gradually, over successive maps, as backfill happens, move PGs from, or if you think about it, move a PG divider. You can think of the crush line as sort of sweeping across the set of PG IDs. So PG IDs will be on one side or the other, and that'll trigger backfill. And you can do that slowly to control the amount of recovery. Does that make sense? It's still deterministic. When you look at a particular OSD map for a particular object, you get exactly one mapping out. But you get to control the rate at which the mapping changes.
Well, so I think going back to what problems you're trying to address with this, one aspect of it is trying to address impact of recovery on client I/O, which I think isn't necessary to address this at the mapping layer. There are other throttling mechanisms that we can use for that quality of service work in that direction as well. But the other direction I thought was interesting here was the idea of not having to do those writes twice. That is redirecting because they're essentially adding new PGs and using those new PGs in their final location already. Not needing to do those extra writes, do older OSDs, and then backfill to perform the same writes again. So Sam, in that kind of scheme you're describing, would it address that aspect of it, that kind of extra write amplification?
No, but that's what I meant by you do have to do the writes to the previous one in the previous location. But I'm not really concerned about write amplification under these conditions, to be honest. I think the core trade-off isn't really about write amplification. It's about whether the final data placement is fully specified by the new cluster map. So over time, you eventually do want that to be true. Just because you don't have to store as much metadata in the OSD map. Otherwise, you have to store an increasing amount of you have to store an increasing amount of location information in the OSD map to account for all of the different decisions you've made in the past. Otherwise, you do eventually want to converge to a single rule. So ultimately, your old objects do have to move. Whether any particular newly created object happens to be written and then moved is, I think, less important. And actually, their complaint wasn't about that. It was about the fact that Crush, in its normal configuration, does do some amount of extra relocation between nodes that wouldn't otherwise have changed. If you look at the original paper, I recall that there was some calculation about how large that set is and how you can tune it. And their own graphs here suggest that delta isn't very big. Figure 2 being the most egregious thin, I think. That's the one with the blue bar that says 60% and the far larger red bar with 6%. But I'm not totally convinced that that's a particular problem either.
Yeah, not sure that measurement is necessarily the most helpful one. Effective number of PGs doesn't tell you how much data is moving, for example.
Yes, it does.
Well, it could be one member of the PG versus all members.
I mean, I see what you mean. Yes, that's true. Still, I'm not as concerned about writing an object twice.
can I get back to my question? I'm trying to understand something you said. There are I can see two options to have multiple, and you talked about two options to have multiple thresholds at the same time. One of them is what? Sorry?
For a particular pool.
Yes. What they are suggesting is to have a specific rule that lets the client know which of the two or whatever, which of the n rules is applicable for a specific object.
For a particular PG. Yeah.
Okay. The other option is to, and then in that case you have to have a rule based on time step or whatever else which we did.
No, the OSD map can just statically say. No, the OSD map can just statically say all PGs under n use the old rule or use the new rule. All PGs over n use the old rule. Then you gradually increase n over time. Like that part doesn't have to be complicated. Okay. There's not a lot there.
Okay, and so that's what I thought I understand. And this case we add very little complexity, it seems, to the system, and we might be gaining something. And the option that you dismiss, I think, is that both rules will be there, and the client will have to try, maybe in an efficient way, just to try one of the rules and get a failure.
No, the client will just statically say if the PGI mapping is less than n, use the new one. That's it. There's no trying, there's no failure.
I understand. I'm saying that there is another option which is less deterministic.
What does failure mean in that context?
You are trying to write, and the OSD answers, I'm not the primary for that specific object.
I mean, they'd be making the decision off of the OSD map also, so it seems like the client could just do that part. Everyone has to agree on who's the primary for a PG, and the OSD map is how we do that. So it's not clear what information the OSD would have in that context that the client wouldn't.
Actually, you're right.
Yeah. One thing also to think about is how this maps onto practical realities of how people expand clusters today. Like this paper kind of assumes that you're adding like a large set of servers all at once, all instantly weighted into the map. But typically you don't do that. You would rather slowly weight them in over time until they reach the full capacity and control the speed of remapping that way. Sam, is this equivalent to your idea of kind of stepping through the old versus new mapping?
Interestingly, no. As I understand it, that gradual increase in weight thing multiplies the amount of extra data movement Crush does quite a bit. That assumption wasn't explored in the original paper, but my recollection from when we discussed this a few years ago was that empirically you do move way more data that way total. I would say that the gradually reweighting part does totally work. Like that's a totally valid mitigation. But that is what it is. It's a mitigation for the fact that Ceph in its current form doesn't do a particularly good job of controlling background movement. And really all the thing where you gradually move PGs from one crush map to another is a more compact way of doing temp mappings. There's no real semantic difference between the two, I don't think.
Right.
Sam, do you know how much space we save in temp mappings?
It's not really about, I mean, if we're a very large cluster, it could be a lot, right? If you have to weight in a lot of OSDs. And it's not space in a general sense, it's space in the OSD map, which can be a genuine problem. But it's only a problem. If it's not, then it's not.
Yeah, that's what I was wondering in terms of like in-memory in-memory usage, for the OSD, right? If you have,
it's not just
that's what I
that.
was
They
looking at.
also all have to process the messages. They all have to interpret the big, it's bad for reasons other than OSD memory.
Yeah. Do we have any idea of kind of what the impact is there?
Well, sometimes it destroys a cluster.
Oh, wow. Okay.
Like that's what this looks like when it gets out of control. If we saw this with the big CERN cluster. It's one of the things that motivated Sage's changes to cutting down peering messages a while back.
There was one thing I didn't completely understand. Maybe, Sam, you can explain it. They're talking in the paper about this parameter we're using in Ceph called OSD max backfills, which makes the migration have the lowest priority. Can you expand on that? Because I didn't really understand what
if
that
you go look at
parameter does.
if you look at the code that controls backfill in the OSD, you'll notice that it limits the number of PGs that can be backfilling at once. And this doesn't change the fact that they're out of place, but it does change the rate at which you make progress in putting them back. So I mentioned temp mappings. So they glossed over a lot of details about how Ceph actually handles this in its current form. But one of them is that when you get remapped to a totally new location on the cluster, you don't actually get remapped. The new primary will say, I'm not a good primary for this PG right now. And it will request an exception mapping in the OSD map that will put the PG back where it was before. Then the old primary will gradually backfill the new OSDs in the background while still continuing to serve I/O at the old location. But the number of PGs that will currently make an effort at making progress at this is limited on each OSD by max backfills. So if you have 100 PGs, all of which are out of place on an OSD, but max backfills is 5 of them will win the race and start backfilling. The rest of them will get line and wait while continuing to serve I/O.
Okay, I see.
And there are other mitigations also.
Yeah, to be clear, the test that they set up was designed to showcase a cluster that was slowed down because they let recovery go so fast. Typically in all HDD case, like they used, you would never use max backfills equals 10 unless you didn't care about client I/O at all.
But also, they're comparing a cluster that's doing relocation to a cluster that isn't. So in many ways, even doing an empirical test here is sort of pointless.
Yeah.
I'm glad their graphs worked out for them, but didn't really need to do that test to find that out.
So it expands a little bit more. We have max backfill is one parameter. The other main one is recovery sleep, which throttles the rate at which we actually perform recovery operations. So those two combined are quite effective at limiting the impact of recovery on client I/O. So it seems like they're. Go ahead.
They're saying that it does essentially mitigate the migration, but they're saying, okay, so you just have less severe performance hit, but just for a longer period of time. So it's not one spike.
So that was my real problem with this test. So I mentioned before there's a distinction between permitting new writes to go to the new locations and relocating old data. And I think I made an argument that you do eventually have to relocate the old data, or you have to carry placement information linear in all of the changes you've made over the lifetime of the cluster, which is what their design does. So I don't think that's possible. I think eventually with this design, you would have to add a way to actually move the old data. And that does mean over a long period of time, data relocation would have to happen. And over that time, there would be an I/O impact. Here, a good job means we do a very small amount of client I/O impact for a very long time. That's what a well-behaved cluster expansion looks like. Their thing where you just don't do the relocation at all is naive, which is not really a detriment to this, a knock to this paper. It just means that that's not something they addressed here. they correctly point out that allowing new writes to go to the new locations does allow you to quickly make use of new resources without client impact, which is good.
Exactly, and I think that's particularly good when you're doing a large-scale expansion. But if you're doing a small-scale expansion, like adding one OSD or like one host at a time, I don't see. You eventually want your cluster to be balanced, or your space usage to be balanced. So you have to do that migration at some point. And whenever you do that, you will bear the cost of it. It's just like choosing to pay the cost at the time of expansion or at a later point.
And with this particular design, they'll also have to pay the cost of PG merging, which is way worse.
Right.
Yeah, you also wouldn't want to do any kind of scheme that involves placing new data only on new hosts if you're adding only a small number, because then you end up centralizing them all and perhaps with a very small failure domain if you're doing a smaller expansion.
Yes.
Actually, with this, that was one trick with this design I rather liked. So there was a bit, I was skeptical of that part. I was wondering what would happen if you added just one host with host level replication. But the way they integrated it into Crush means that you will put the other replicas on the old portions of the cluster.
What about if you had 3 hosts, though?
It will tend to find all of them, but you haven't actually violated your Crush rule at that point.
No, you've just created a new separate, a special group that is now all overloaded. And, yeah. Essentially mirrored pairs.
Josh, with the QoS work that's been ongoing, how do we have any idea how good that is right now at kind of achieving the slower, delayed behavior for background work? Do we have anything like demonstratable yet?
Yeah, Sweetheart has like 70 pages of experiments that you can look at.
Okay, cool.
It's still ongoing investigation to some aspects of it, but it's definitely looking very promising.
That's great. That's really good.
But again, that's kind of addressing the rate of recovery issue. Like it doesn't address the thing that Sam brought up, which is the overall how much data we're migrating, which is something we can't control as easily today.
Well, I'm kind of arguing that we don't want to. Like we don't want to give we don't want to give users the ability to leave their clusters in this sort of memory-ridden state. Like we don't.
Oh yeah, sure.
Want this. We want eventually a cluster to converge to what it would look like if it had been created fresh, more or less.
And if we're doing that, do we gain anything with this? Do we still gain having data placed on the PG they're going to end up? Is that still a write amplification gain, or is it not?
Given that you then have to merge the PGs, yes.
Okay.
Because you can't just double the number of PGs every time you make a modification to the cluster.
Yeah.
PGs are more than absolutely any of this.
But the idea of Sam, your idea about changing the replication over time rather than retargeting and adding new PGs, that seems like it could be helpful.
Yeah, I mean, we discussed it in the past. It like I said, all it really amounts to is the thing we already do in the monitor, or the pre-remapping. I forgot the name.
Prime PG tab.
Yeah, but the thing where the monitors predict which ones they need to put into the map. It's basically that, but more compact and a little bit easier on the monitors. There's no other actual difference.
So Sam, you're basically arguing then that the behavior we want combined with what else it does really ultimately doesn't result in any kind of write amp benefit.
I don't care about
Is that
write-downs,
right?
is what I'm saying. I think many of the
Yeah, I agree with you.
things
Yeah,
here
yeah.
result in write-downs, so that's not an interesting metric.
Yeah.
The interesting metric is how, like, the real star power of this paper is that newly created objects go to the new location. So that's cool. I don't like the way it does it because of the increase in the number of PGs. But some other combination of like information carried by the RBD info or something could be interesting. So I think there are interesting concepts here. However, I think that the thing where you just change the rate at which data moves can be accomplished much more simply, either by beefing up the thing in the monitor where they predict what PG temp mappings need to exist, or by doing the thing I suggested where you just expand the OSD map a little bit to permit multiple crush maps for a particular pool and a dynamic cutover point that can be updated with successive OSD map epochs. I think a lot of these mitigations could be interesting, but I don't think that any of them are silver bullets in that it's still the case that you need to handle the data movement when it actually happens without swamping client I/O. And I think that's the real problem here. Even with this approach, eventually you have to do this layer merging thing, which does result in data movement. And then you have to do PG merging, which is far more expensive, both of which will have client impacts that aren't fully measured here. And in either of those cases, something like QoS will still be necessary. So this isn't really a replacement for that effort.
Maybe we're thinking more about that prime PG temp piece. I mean, that's all calculated
prime PG temp
currently on leader monitor, so you're limited to a single host CPU power.
Yeah, so in that sense, the thing I outlined is I think a solid thing. Like it's a good thing. It's just that it won't replace QoS. It's better thought of as a better PG temp priming than it is as a QoS solution.
No, I'm not saying it's at all replacing QoS. I think those are kind of orthogonal axes.
Right. That's what I'm trying to outline that part. But yeah, I think that approach could be interesting. It's a little weird because you need to be able to support situations where there are 3 or 4 maps in place, but I don't know that that's really that big a deal either. The administrative component might be a little rough. You need to build something into the manager to make sure that this line advances. I think that was a major argument against it the last time this came up, which is that we didn't have the manager component. We didn't really want the monitors doing it. But with the managers getting some kind of a cluster-wide snapshot, they could be in charge of advancing the line over time as recovery work.
Yeah, exactly. I think there's already a manager module that does the reweighting in weighting of OSDs over time, but it could easily do this,
exactly.
Moving the line over time instead.
Are we all just sitting in quiet contemplation now?
I'm just trying to figure out like what is the main like conclusion that we have from this? Because there's certainly, I think, that bring it up some good points, and it seems like there are some stuff that would be interesting to take away from this. I mean, the point of this was not, implementing exactly that, because that's obvious that there were problems with that. I mean, it's a scientific paper, so it was obvious that in the evaluation as well, they were doing stuff that, they were manipulating sort of like the results in their favor. But what I want to know is if there are stuff from that paper that we would be interested in checking or trying ourselves or performing our own experiments or stuff like that.
Well, the big problem with this paper is the extra, or with this approach rather, not with the paper, is the extra information you need to store to placement. It's not generalizable to RGW, for instance. So it would mean adding a Rados pathway that's specific really to RBD. I don't like what they did with StephFS here. I don't think that's actually going to work. Well, maybe. I also don't really like tying it to time. I think there are other interesting things you could do with a key like that would be more general than just time, though that would be potentially interesting. But because of the limitations on PG merging and the details with what this does to a cluster over many years, I don't think that it's worth actually evaluating this approach directly. Like, we don't need to do experiments to know that increasing the number of PGs manyfold over the original correct number isn't going to be a good idea.
But Sam, what you talked about earlier, having a line that we can control how it moves, is this something that worth implementing?
Yeah, I mean, I think it's probably a good idea. I don't know how urgent it is. Like I said, it doesn't actually solve the QoS problem. It is essentially a better version of PG priming. So the question, or it's a cheaper for the leader monitor version of PG priming. So the question is, how well does PG priming work? Like, do we find that it frequently fails to map enough PGs? Do we find that the space overhead in the OSD map is in practice too large? If so, then yeah, that might be something to go into. If not, then it seems like a cool thing that probably won't actually gain us anything.
Yeah, I think in the short term, there are kind of more improvements we could make to the PG temp priming mechanism directly, where currently it tries to do a bunch of work and then kind of throws it away if it doesn't get it done. And there are other aspects of how we're doing some PD calculation in the monitor right now that, for example, should be split up into finer grained pieces or done in a worker thread outside the main monitor lock. But I don't think we've seen really many problems from the space used by the temp entries, but I'm not sure we have a great measurement of how often the priming itself is helpful versus just ends up timing out.
I seem to recall back the envelope math from Sage back when he introduced it, or last time I talked to him about it, that suggested that it's really a small cluster thing. For a large cluster, you'll never have enough monitor CPU cycles available to do the job. So under those conditions, it might be worth exploring the other thing. Also, the other thing is in some ways simpler. Like, you're not relying on the monitor to burn a bunch of CPU to solve this problem. It's just simple and deterministic. So it might be worth implementing for that reason.
And it's quite a nice property that it's not linear in the number of PGs. It's
right.
A small change over time. You don't need to do all in one gigantic map update.
And unlike reweighting, you don't end up removing PGs multiple times. They will go to their final location immediately.
Exactly.
So this seems like something you do if you observe that we are seeing large cluster problems, or we're investing actual effort in making PG priming really clever in terms of worker threads or something. That might not be worth it. But if the current version works, then not sure.
Do we know if we do see that on large clusters? I have no idea.
Well, it's also the case that the larger the cluster gets, the less these expansions matter.
That's true.
Not that they're ever totally irrelevant, but it's those things where you're like doubling the size of a cluster that are truly rough. When you're just adding a rack to something that already has 30 racks, it's a little bit less catastrophic.
Yeah, and the part about the double data movement does increase the total time of migration like this. So it is nice to kind of optimize that, but it's probably not most pressing problem. Like Ron was saying earlier, this is kind of a cost that you're paying one time. It's not something that continues to be an issue over the whole life of the cluster.
Yeah.
Hi, I have one question. Do they have this open source, the MapX code? Can someone find on GitHub?
No, so I haven't tried searching for their code. I did try to email them if they want to come to one of our meetings and present their work and maybe answer a few questions, but I didn't get a reply. That's why I asked Mark earlier if I CC'd you and Josh. Did you guys get that email? So I'll know that the email was indeed sent and it's not a problem on my end, but just them not replying yet.
Yeah, the email came through.
So yeah, they just didn't reply yet. So ideally, if they, if they could come to one of these meetings and answer any questions you have, or provide us with some code, then yeah, that'd be nice. But as soon as I will have an answer from them, I'll update.
Okay, I think in the email to this performance meeting, it was mentioned. So I thought the presenter itself will be present. That's why I asked. Okay, because it says a research paper Avnum Hanukov presented last week regarding the drawbacks of the crash algorithm and the MapX crash extension. So a MapX crash extension paper is okay. It's in the email, but is there any other paper as well we're discussing?
No, that's the paper we're discussing.
That's the only paper, MapX.
Yeah.
But in the email is mentioned the paper Avnum Hanukov presented last week.
Yeah, so, that's me. That's me.
So which paper you presented?
No, this one, like MapX, I presented as in well, I talked about it with the team that I came across the paper. I didn't present it as in I wrote that paper and presented it to the team.
Okay. Perfect. Sorry for my confusion. Yes.
No worries.
Well, we are getting close to the end of the hour here. So is there anything else that folks want to kind of talk about before we run out of time here, related to the paper or otherwise?
Actually, it occurs to me that this is specifically inapplicable to the case where it would be most useful. RGW workloads create a lot of objects, but RBD and CephFS workloads may not. Well, maybe CephFS, but not RBD. RBD only creates objects at the rate at which you create new RBD images. Sort of a limitation here. Sorry. Go ahead.
Was someone else trying to talk as well?
No, I was just about to say, so like I think we can probably conclude, I guess, like what are our next steps? Are we like just a conclusion from the paper, if there is something we want to look at further or no, or maybe look at it another time? Yeah.
It sounds like it's given us some interesting ideas about how we could try to address extra data migration. That was a significant problem that we saw. But to me, it doesn't seem like it's the highest priority sort of issue, though.
My 2 cents from the paper is that the problem that they're trying to address is genuine, but is not as impactful to regular Ceph clusters life as that we. Also, the approach that they've taken does not consider some important aspects of creation of new PGs and PG merging, extra cost and everything like that. So the approach, I don't think, is something we would want to explore further, but probably go back and look at our prime PG stuff that we already have and see whether we can, whether it's adequate enough or whether we can optimize it further. Is probably my key takeaway from reading this paper and having this discussion.
I think the comment that was made earlier about graphs was kind of spot on. It feels like a lot of the things that they have here were kind of designed to make the graphs work.
Yeah.
Nothing is not real, but it's just
So as a common problem with papers that need some good data to publish something, so often the experiments aren't not quite matching up with the real world deployment.
Yeah, exactly.
Well, I would say their experiment nailed it. It's actually, yes, you do affect client I/O less if you don't do data relocation. That is true.
Are there any other papers people have been noticing that might be interesting to discuss in the future? Has anybody taken a look at the other papers from FAST this year? I haven't got a chance myself.
I have to look. I'll take a look this weekend.
I'll let you know if I do. I'm trying to read a new paper every single week. So
hey, yeah. If folks are interested in this, and it looks like they are because we have a pretty big attendance this week, let's do it.
Once upon a time, we had a journal club. It'd be nice to come back. That would be fun.
So I'm just going to say that if we are interested in that, just in that STEM made, then I can definitely take a look into that and make time for that. But yeah.
Cool. Yeah. Maybe. Well, does anyone want to try to propose a paper for next week? Either Amnon or Josh. Anyone want to take on that?
I mean, I can take a look. I'm probably gonna read some more papers this weekend. So if I'll find anything, I'll for sure bring it up. But
okay.
Once again, this paper was pretty random the way I came across it. I just I was at the website and I just searched the keyword Ceph, and then this is the first thing that came up. Well, because it was the newest one, so I started kind of reading through it, and that's when I thought that maybe it would be worth bringing up in performance meeting.
Sure. Would we?
I think this is the latest one.
Sorry, what was it?
I think this MapX is one of the most latest one, which I have also found from the research community. Because I'm a novice. I'm still working on Ceph, completely new to Crash, but I've been reading just basically the paper from Sage and to understand the Crash, and then I came across this MapX. Apart from that, I would be really interested if there's something more based on Crash.
Would if we do start doing this regularly, do folks want to do this every week or every other week or every month? What would folks be interested in?
Probably every month or every 2 weeks or something. So we have time for other topics too.
Yeah.
Mark, maybe you can
Look at
make
that.
an announcement with the performance meeting heading and ask people to add papers to your Etherpad. That way, everybody can add papers and we can decide which one we want to read together.
That's a great idea, Neha. You can, if you want to, you can edit it here directly too. It's not mine.
No, I mean, I just want to say that people should know that we are discussing papers or reading papers together in the performance call, so that, like, some people did notice it today. So it's a common theme that people would may be interested in joining.
Mark, can you link the patch he's talking about? Or?
Yeah, here, give me 1 second. This is the pad right here. I try to send out a link to this in the email. It goes out to the dev list. But here, I added a potential discussion papers. Maybe depending on how many papers people actually put in this, we can figure out what a schedule would look like. If we only have 5 papers, maybe we only do it once a month.
Yeah, I mean, I think it's a really good idea, because then, there's a lot of new papers coming out, and it's important to, be on top of that and see maybe if there is something new that, that we didn't notice before. I mean, even from this paper, even like the MapX paper, even if we don't, take, if we don't implement that, it's just some nice stuff that, key takeaways we can take and that make us think or rethink stuff. So I think it's really important.
Cool. All right. Well, then everybody add your papers if you find them, and I'll send out a announcement on the mailing list that we're thinking of doing this, trying to figure out a schedule and see what happens.
Okay, cool. Sounds good.
All right. Well, have a great week, everybody.
Have a great week.
Thanks.
Bye. Thanks.
You too.
Yep.
You too.
Yeah,
thanks
again for the paper.
Thank you for taking the time to read it seriously. I appreciate that.